Greetings, chemistry students. Today we're going to be talking about the concept of pH and its close cousin yet opposite, pOH. Now, pH is the negative logarithm of the hydronium ion concentration. I know that sounds like a lot of complicated words, but this is actually some of the simplest math you'll ever do. So, this is the formula. It's found on your reference tables on page 3 on the equation sheet. You'll notice there's actually a lot of things that have like pH and OH in them. We're going to be going through actually like all 6 of those. So pH is the negative log of the H plus concentration. Now I'll explain how we're going to figure all this out in just a minute. pOH is the negative log of the hydroxide ion concentration. So pOH equals negative log of OH minus concentration. Now, there's another weird thing that's always true when we're dealing with solutions in water, and that is that if you take your hydrogen ion concentration and you multiply it by your hydroxide ion concentration, it equals 1 times 10 to the minus 14th. That's what's called an equilibrium constant for water. You don't need to worry too much about that now. But essentially, those two things, H plus and hydroxide multiplied together, they equal a constant. And if you were to take the negative log of both sides of this, if you've learned this in your math class and you remember how to do this, you take the negative log of the left side of this equation and the negative log of the right side of this equation, essentially you get, this simplifies out to say the negative log of H plus times the negative log of OH minus equals 14. And so this kind of simplifies to tell you that pH plus pOH equals 14, which is about the simplest equation ever. If your pH is 2, your pOH must be 12 because 2 plus 12 is 14. If your pH is 6, your pOH must be 8. If your pOH is 7, your pH must be 7 because 7 plus 7 equals 14. We're only going to be working with whole number values here with the logarithms, so don't get freaked out. You don't even need a calculator for any of this. I'm going to make logarithms super simple. So these are the problems that we're going to look at. There's 7 of these, and then I'm going to actually work through them with you because we're wanting to calculate both the pH and the pOH. So for this first one, if your H plus concentration is 1 times 10 to the negative second, I'm going to have to write the answer to number 1 over here. Your pH equals the negative log of 1 times 10 to the negative 2. Now, the log of 1 times 10 to the negative 2 is just negative 2. That's all you do. If it's 1 times 10 to the something, when you take the log of it, you just take the exponent. If we take the negative log, we take the negative exponent. And negative 2 is just 2. And then for the pOH, well, what plus 2 is 14? 12. For number 2, our pH is going to be negative 6 or just 6. So our pOH is 8 because 6 plus 8 is 14. For number 3, in this case, we're given a hydroxide concentration. So when we take the negative log of this, we're finding the pOH. And the negative log of 1 times 10 to the negative 7th is just 7. And so the pH is also 7 because 7 plus 7 is 14. If our hydroxide concentration is 1 times 10 to the negative 6, our pOH is 6 and our pH is 8. If our hydroxide concentration is 1 times 10 to the negative 4th, then our pOH is 4 and our pH is 10 because 10 plus 4 is 14. Number 6, we have a H plus concentration, so our pH equals 9. Our pOH equals 5. And then number 7 is a bit tricky. I just want to show this to you so you kind of understand this. 0.001, if you write this in scientific notation, that would be written as 1 times 10 to the negative third, because you move the decimal point 1, 2, 3 spaces to the left. So your pH is 3, and the pOH is 11, because 3 plus 11 is 14. So let's take a look at the answers real quick. There we go. And then we're going to look at a few more things. We need to reverse this process. If I give you the pH and ask you what the H plus concentration is, well, the H plus concentration is 10 to the negative pH. And your hydroxide concentration is 10 to the negative pOH. So if I told you that your pH was, I don't know, 13, then your H plus concentration is 10 to the negative 13. That would also mean that your pOH is 1 and your OH minus concentration is 10 to the negative 1. And keep in mind, there was this other formula that says if you multiply H plus and hydroxide concentrations together, you get 1 times 10 to the negative 14. Well, if you multiply those two things together, remember your law of exponents, you add the exponents, so you would get 10 to the negative 14. It all works out. I want to consider one last scenario here. If your pH, well, I want to consider one last scenario here. If your H plus concentration is 1, then your pH equals the negative log of 1. Well, the log of 1 is 0, and negative 0 is still 0. So your pH is 0. Because the reason this is 1 is because 1 in scientific notation is written as 1 times 10 to the 0th power. And so that's where that 0 comes from. So if your pH is 0, your pOH would be 14, and your OH minus concentration would, of course, be 10 to the negative 14. So now we're just going to look at one last thing, which is, what does all of this mean? What do these numbers actually mean to us as far as acids and bases? Well, a substance with a pH of 7 and therefore a pOH of 7 are considered neutral. If your pH is less than 7, which also means your pOH is greater than 7, you're an acid. And if your pH is greater than 7 or your pOH is less than 7, you're a base. So I can summarize this by looking at a pH scale. We'll put a 7, we'll put a 0, we'll put a 14. If this is a pH scale, then this range down here is acid. This range is base. And then 7, of course, is neutral. It's neither acid nor base. If we're looking at a pOH scale, it moves in the opposite direction. So down here is base, and above 7 is acid. And yes, it is actually possible for you to go below 0 or above 14. We're not going to really work with those cases in this class, but just be aware that is possible. So if we go back to this first set of problems. So for number 1, I just want to classify some of these. For number 1, with a pH of 2, that's an acid. Number 2, with a pH of 6, It's less than 7. It's also an acid. For number 3, our pH and pOH are 7. That's neutral. For numbers 4 through 6, our pH is greater than 7. So those are bases. And for number 7, our pH is 3. So that's an acid. You could also do the determinations based off the pOH scale. You'll get the same results. So last thing I've got for you today is a few problems for you to test and see how well you can do this. So good luck.